Okay.
All right. So yesterday we started with number systems and we saw that there are two types of numbers, that is rational numbers and
Irrational numbers.
irrational numbers. Correct. Now, both of them, when combined together, they are rational numbers. They are real numbers. Okay.
Yes.
So we can say that real numbers are the collection of all types of numbers that exist in the universe. Okay. Is that clear, Khadijah?
Yes, ma'am.
All right. Now, irrational numbers were further divided into three categories, that is, integers, whole numbers, and natural numbers. Please tell me the difference between them.
Integers. Integers, they are negative and positive numbers.
Okay. The numbers which
Whole,
include negatives and positives.
whole number are those that start with 0 to infinity.
Okay.
And natural number are those that start with 1 to infinity.
Very good. So natural number starts with 1, whole number starts with 0. Integers can be divided into two categories, that is, positive integers and negative integers. Okay?
Yes.
All right. Then we saw the decimal expansions of different numbers, right? So how many types of decimal expansions are there?
Terminating decimal, non-terminating, repeating, non-terminating and recurring, terminating, non-terminating and non-recurring.
Speak slowly and say again.
Terminating decimal, non-terminating and recurring,
Correct.
recurring, non-terminating and non-repeating.
Okay. Can you please tell me the difference between these three types of decimal expansions?
Yes. Terminating decimal are that terminating means to end.
Okay. So what does it mean? Means to terminate or to end? What are we ending here? Yes, Khadija. Terminating decimal expansions means the decimal expansions which terminate or end. So, what do you understand when we say this, that the expansion is terminating at one point? We're talking about the division here.
Yes.
Khadija, are you there?
Yes, ma'am.
Okay. So, we are talking about the division here. So, those numbers which are divided and the division of those numbers end at one point or terminate at one point, they have a terminating decimal expansion. That means you get a zero as the remainder. Okay.
Yes.
When you're dividing them, the division ends at one point, you get a zero and that's over. So that is called a terminating decimal expansion. Now, what do you understand by non-terminating and repeating decimal expansion?
Non-terminating repeating decimal expansion is that it terminates, mean it doesn't stop and it repeats the number.
And no, you are confusing. Non, you're reading the word as non-terminating, but you are saying that it terminates at what at one point. These are two opposite things. Non-terminating means the decimal expansion, which is
Terminate Non-terminating is that
you're
continuous
not getting
infinity.
a zero as your remainder. The division, yes, the division continues and it never ends. Okay, but what do you understand by recurring or repeating when we say it together, non-terminating and recurring? What does that mean?
Non-repeating non-repeating
Please
non.
excuse me for 1 minute. I'm sorry.
Yes, ma'am.
Yes. Khadijah, am I audible?
Yes, ma'am.
Okay. We were discussing what do you understand by non-terminating and repeating decimal expansion?
Non-terminating and repeating decimal expansion.
The meaning is there in the word itself. Try to decode the word.
A decimal number that continues infinitely without end.
Oh, what a decimal number continues. No, just decode, just break the words and then understand the meaning. See,
With a sequence of digit, it repeats.
yes, now you got it right. Non-terminating means it is not ending. Okay, the division keeps on going. And repeating means the digits that you are getting in your quotient, they are repetitive digits, means same digit is repeating again and again. Okay, for example,
Yes, in sequence.
0.999999 and so on. So this division is not ending and the digits are same. Okay,
Yes.
okay. Now, what was non-terminating and non-repeating?
A decimal number that uh, goes infinity and with, without any pattern of digit repeating.
Correct. When the division, you don't say the decimal numbers that go, you can simply say that the division does not terminate and the digits are also not repeating. Okay.
Yes.
For example, it can be 0.100100, one four zeros. So there is no pattern of repetition here and it's not ending also. Okay.
Yes.
Now, these three types of divisions that we studied, we saw that two of them can be seen in rational numbers and one is seen in irrational numbers. Can you tell me which one is seen in which types of numbers?
Terminating, non-terminating, and repeating is rational.
Okay, please say loudly.
Non-terminating and non-repeating is irrational.
Okay, this is irrational.
Terminating decimal, non-terminating, and repeating decimal are rational.
Very good, very good. So just remember one thing, wherever there is non-terminating, non-repeating decimal expansion, it will be an irrational number. Okay?
Yes.
All right. Yeah, that was it. So today we'll be starting with a new topic. I hope these questions were clear for you how to find rational numbers between two given numbers. You just increase the
Yes.
range. Okay?
Yes, ma'am.
All right. Now, root 2, root 3, root 4, root 5. These are what kind of numbers?
These are irrational.
Yes, these are irrational numbers. Why? Because their decimal expansion is non-terminating and not repeating. Now we'll see how to plot them on the number line. You know what is a number line?
Yes.
So yeah, this is the number line. We have written all the digits here, all the numbers like this, and these on the negative side. So all the real numbers that exist in the universe, that is rational as well as irrational, all kinds of numbers, they all have a specific position on the number line. Okay, each of those number has some position on the number line. You can't say that this number will not lie on the number line. Okay,
Okay.
all right. Now we'll today we learn how to plot these numbers on number line. So let's start with root 2. Okay, so how can
Yes.
you write? Okay, before that, uh, have you heard of the Pythagoras theorem?
No.
You haven't learned Pythagoras?
No.
You must have, beta. It's ninth. Okay, no problem. See, you know, this is a right angle triangle.
Ah.
Remember something?
Yes.
Okay, so this is a right angle triangle, which means this one angle is a right angle, a 90 degree. So the opposite side to this angle is the hypotenuse, which is denoted by h. It is the longest side of the triangle. The bottom side is
Yes.
the base, while this standing line is the perpendicular. Okay.
Yes.
So this hypotenuse is written as, we have this Pythagoras formula that,
A square plus B square.
yes, hypotenuse is equals to under root of p square plus b square. Okay.
Yes.
Now we'll denote this root 2 in this form. So how can you write 2? You can write 2 as 1 plus 1.
Yes.
So we can write 1 square. We can take perpendicular as 1, base as 1. So 1 square will be 1 only, and base 1 square again 1, and then under root. So this will be your answer for root 2. 1 square plus 1 square in square root. Got it?
Okay. Yes.
How to denote this on the number line? How to put it, plot it on the number line? So we have this line 0, 1, 2, 3. Now I have taken these as 1 units. Okay, this is 1 unit, this is 1 unit, this is 1 unit, and so on. Is that clear?
Yes.
So now for root 2, my base is 1 and my perpendicular is also 1. Is that clear?
Yes.
So from 0, I'll take 0 as the origin and I'll draw a 90-degree angle using a protractor. You know how to draw that 90 degree?
Mm-hmm.
This is this kind of device. Do you have? It has all the angles marked.
Yes.
A semicircular kind of thing, that's a protractor. We use it
Yeah.
to draw the angles. So you will put it on
Okay.
0. You it has a 0 point. I don't have a protector here. I'm very sorry. So I'll have to explain you like this only. So you will put your protractor over 0 and then you will draw a straight 90-degree angle. Is that clear?
Yes.
Then measure this line. Okay, this is a 90-degree angle we have. So this is 1 unit.
Okay.
Now take 1 unit on your scale, measure it on the compass, and then put an arc here. Put your compass here on this point 0 and put an arc here. Okay?
Okay. Okay.
So this will be 1, right?
Okay. Yeah.
Now this perpendicular is 1, this base is 1. Join this, one second. Join this point with this point using your scale, and this hypotenuse will be root 2. Is that clear?
Yes.
Now, when you plot it on the number line, it is still not on the number line. We have just drawn the triangle. So how will you mark it on the number line? Take your compass again, measure this line, measure this line. Okay, put your compass needle here and then your pencil here. Whatever length you get, you have to mark it on the number line. How you mark? Put your needle of the compass on 0 and then make an arc here of the same length. Okay, so it will
Okay.
lie here between 1 and 2 somewhere. So this is your root 2 on the number line. Is that clear to you?
Yes.
Okay, I know it was a bit difficult for you to understand it without compass and the proper instruments, but I hope you got an idea how to plot under root numbers on number line.
Yeah.
We'll revise it once again. Okay, it will become much clearer.
Okay.
So, first of all, how you denote root 2. Yes, Khadijah, how? Sorry for the background noise. How do you denote root 2? Khadijah, are you there?
Yes, ma'am.
Please give the answer. How will you denote root 2 using Pythagoras theorem?
First, we mark here number line.
I'm not asking you about the number line. Just 1 second. Okay. There is some background noise. Sorry for that. Please bear with me today. No, I'm not asking you about the number line as of now. We are just discussing how will you denote root 2. You can write it as 1 square plus 1 square.
Yes.
Yes or no?
Yes.
Okay, take it this way. How can you write 2? Break 2 into 2 parts. The addition of two numbers will be 2.
One.
What are those numbers? 1 and 1, right?
Yes.
Just do the square of them. Under root 2 means 1 square plus 1 square in under root only. Okay?
Okay. Yeah.
Now, how will you make the triangle here? 1 unit is the base, 1 unit is the perpendicular, and root 2 is the hypotenuse. Got it?
Yeah.
Okay. Now we learn how to plot it on the number line. So you have this number line. These are all 1 units. So we have our base 1.
Also, we are doing 90-degree with that.
Yeah. Now what will you do? You need to make a triangle here using this as your base.
Nine. First, first we make 90-degree angle straight.
Where
Then from
Where do you have to make the angle? You're making a 90-degree angle, but at what point?
0.
Yes. So say the complete sentence, okay? That draw a 90-degree angle here on 0. Then
Mm, we have to make the arc.
where and of what measure? Khadijah, where will you make the arc? You already have this line of 1 unit. You have drawn a straight line here. So where do you need one more unit? This, na?
Yes.
So you will make the arc on this line. Just say this. Okay?
Okay.
So you will mark 1 centimeter arc on this line. So you have 1 unit here. Now join.
Ma'am, one a 90-degree angle with the scale I have to mark.
No, no, no. First, you will make the 90-degree angle using the protractor,
Okay.
and then using the compass, you'll make this arc, not using the scale.
Okay.
Okay.
I asked it because our teacher did like this only. He
See, you
thought
can
that.
do it with a scale also. It's not wrong. But in the next step, when you will be marking root 2 on the number line, then also you will need the compass only, right?
Yes.
So why not work with the compass only so that you get your proper measurement?
Okay.
Okay, doing with the scale is not wrong, but it's more feasible to do it with the compass. Okay, so now this point and this point, connect it with the line. Yeah, sorry. I hope now the voice is not coming.
Yes, ma'am.
Okay, so this will be root 2, right?
Yeah.
Now measure this using your compass and your pencil. This root 2, and taking 0 as your origin, make an arc. So it will come somewhere in between 1 and 2. So this will be your root 2. Got it?
Yes.
Okay. Now we'll come to root 3. So for why did I teach you root 2 first? Because first you have to make root 2, then only you can make root 3. Okay. So how can you write 3?
And when we do with that compass, that we mark arc in between 1 and 2. So in like in between we can mark anywhere from 1
No,
and 2.
no. You don't have to mark anywhere, Bita. You have to take a proper measurement. Why are we making this line? Why have we joined this triangle? Huh? You have to measure this line. Measure this using your compass and using the same length, make an arc. So it can come here also, here also, here also, anywhere between 1 and 2. You can't just mark a random arc. Okay? You need a proper measurement of root 2 line, which is this hypotenuse, and then you need to mark it on the number line. Got it?
Okay. Yeah.
Okay. Now we'll come to root 3. How can you write root 3 as addition of two numbers?
One one square.
Just tell me the numbers, don't tell me the squares right now.
Okay, 1 plus 1 plus 1.
I'm asking you two numbers. Addition of two numbers. You need one perpendicular and one base only, na? You don't need 3 digits.
1 plus 1.
1 plus 1 is 2.
1 plus 2.
Yes, 1 plus 2, you will get 2 digits. So 1 plus 2 is 3. Now it's under root. Okay, we need to do the square. So 1 square will be 1 only. Okay, but you can't do
Yes.
2 square. Otherwise, it will become 4 greater than 3. So you will do
Yes.
under root 2 square.
Okay.
Okay, so under root 3 can be written as 1 square plus under root 2 square and then whole under root. So 1 square is 1 only. Root 2 square means when you multiply two root numbers which are same, it is the whole number. So 2, so it's root 3. Okay, that is why we have taken under root 2. Got it?
Yes.
Now we know that root 3 is 1 square plus under root 2 square. Okay,
Yes.
so sorry. We have already learned how to mark root 2 on the number line, right?
Yes,
0,
ma'am.
1, 2, 3. You'll make, this is 1 unit. You'll mark and you'll make 90-degree, cut an arc of 1 unit, join this. This is root 2. Measure this line, cut an arc somewhere here. So this is your root 2. Is that clear?
Yes.
Was that clear?
Yes, ma'am.
Okay. Now we have to mark root 3. So for root 3, the base is 1 and the perpendicular is, sorry, this is p square, this is b square. So base is root 2 and the perpendicular is 1 square, right?
Yeah.
So now we have root 2 here. So this is the base of your triangle, correct?
Yes, ma'am.
So from this point, you will make the 90-degree angle. You will cut an arc for 1 centimeter and then you will join these 2 points. Okay?
Okay.
I have followed the same exact method as I did for root 2. It's just that I have changed the position of the triangle now. Are you getting?
Yes, ma'am.
Okay, so now this hypotenuse is root 3. Got it?
Yes.
Okay. Now, we need to mark it on the number line. So what will you do? Measure this. Okay, on the compass.
Yes.
Then take 0 as the origin and make an arc. So you will get it on the number line. Okay?
Yes, ma'am.
Is that
Ma'am,
clear to
this
you?
root 3 I
You
didn't
have to follow
understand.
this.
Can you explain me one more time?
Yeah, no problem. I'll explain it again. So, did you understand till root 2?
Yes.
Now, what I am doing, root 3 is 1 square plus under root 2 square, right?
Yes.
So, I have this triangle where base is root 2, height is 1, and now hypotenuse is root 3. Is that clear?
Yes, ma'am.
So, you need the base of root 2. Where is root 2? This line is root 2.
Mm-hmm.
So,
Yeah.
this will be your base. Now
Yes.
from this point, you are getting your 1 unit perpendicular. So make a 90-degree angle, cut an arc of 1 centimeter or 1 unit. This will be your perpendicular. Okay.
Yes.
This root 2 is your base. Now you have to join these two sides now to get root 3. So from this arc, to this point. Join and complete the triangle. This line will become root 3.
Okay.
Understood now?
Yes, ma'am.
Okay. Now, if you have to make root 4, so can you tell me now how will you make root 4? You have to follow the same
Two.
method.
Yes, ma'am.
You have to follow the same method. Root 4 can be written as 1 square plus root 3 square, right?
Okay. Yes.
See, always remember when you solve, when you doing this number line questions, root 2 will be 1 square plus 1 square.
Ma'am, if they tell to like do root 3, so first I have to do root 2, then I have to do root 3.
Yeah, it will be in continuation only. You cannot draw root 4 directly. First, you need to draw root 2, then root 3, then you will draw root 4.
Okay.
Okay, so just remember one thing, root 2 is 1 square plus 1 square, root 3 is 1 square plus root 2 square, root 4 is 1 square plus root 3 square, root 5 is 1 square plus root 4 square.
Mhm.
Got it? So it
Yes.
goes this way. Is that clear to you?
Yes, ma'am.
Okay, so for root 4, you have 1 and root 3 as your base and perpendicular, correct?
Yes.
So where is the base of root 3 in this number line? You can see this here, root 3.
Yes, ma'am.
So take it as your base. We have our base. Now, from this point, draw a 90-degree angle, cut an arc of 1 unit, and join these 2 points to complete your triangle. Got it?
Yes.
Okay. So you have root 3 base, 1 perpendicular. This line will be root 4. Is that clear?
Oh. Yes, ma'am.
Now, how will you draw root 5? Take root 4 as the base. One second.
Root
From this
4 is the
point,
base, then 1 centimeter arc,
yes, and then
then connect that till like 1,
you'll get root
and
5.
then measure this line and then make the arc.
Yes. Now measure
That
this
is 5
every
degrees.
time you have to
Right.
measure, okay? Measure
Yes.
this and put an arc on the number line. Got it?
Yes. And that is root
You
5.
can continue root 6, root 7, so on. Okay?
Yes.
All right. So I hope number line was clear to you. Now we'll come to
Yes,
our
ma'am.
first exercise.
And by making this, it's like confusion that like base and that 90-degree angle, that confusion I have in root 4 and root 5.
Means, what is the confusion? Tell me again.
Like root 2 was simple, it was straight triangle, it was straight like this only. Then, but in root 4 and root 5, it's going from other direction.
Yeah, because see, when you will connect this, no, root 2, root 3, root 4, it will complete a circle. A spiral will be formed. Okay,
Okay.
not a circle, a spiral figure will be formed. So there, because this is because the directions are different. But no problem. When you're drawing, you can. This is a laptop screen. I cannot tilt my laptop. But when you're drawing it on a notebook, you can tilt it. No.
Yes.
Tilt it and make your base straight. That's it.
Yeah.
Otherwise, it is the same thing only. Base, perpendicular, hypotenuse. Then base, perpendicular, hypotenuse. Then base, perpendicular, hypotenuse. Then base, perpendicular, hypotenuse. This way only it's going, no?
Yes.
Okay?
Yes, ma'am.
Any confusion? Just take your time, understand, look at the figure properly, and then ask me, do you still have any doubt? I'll clear that.
No, ma'am.
If you want, you can practice this by yourself. Try to draw root 2, then root 3. Okay? And then if you still
Yes,
have any
ma'am.
confusions, we'll discuss it. Got it?
Okay. Yes.
Okay. Now, we'll come to the exercise. So, yesterday we completed exercise 1.1. Today we'll be starting with 1.2. Please open your textbook.
Yes, ma'am.
Okay. Have you opened?
No, ma'am. 1 minute.
Khadijah, why are you taking so long to open your notebook?
Yes, ma'am.
Okay. Now, please read the first question.
State whether the following statements are true or false. Justify your answers. Every irrational number is a real number.
Okay. So, every irrational number is a real number. Do you think it's true or false?
False.
Why?
Because in real number there is rational and irrational both.
In real number, it includes rational numbers also, as well as irrational numbers also, right?
Yes.
So, this is the question, no? Every irrational number is a real number or not? What is irrational number? It is a type of real number only, na? So
Yes.
yes, all irrational number comes under the category of real numbers. So they are all real numbers. So it's true.
Okay.
If I reverse the question, all real numbers are irrational, then it will be false. Because real numbers are not irrationals only. They also include rational numbers. Got it?
Yes, ma'am.
Okay. Please read the second question.
Every point on the number line is of the form root m, where m is a natural number.
So we just studied under root numbers on the number line, how to plot them, right? So the question is saying that every point on the number line is of the form root n, okay? Where m means the number in this under root is a natural number.
True.
Why?
So there is root 2, 3, 4, 5, and that all are natural number.
Root 3, 4, 5. Sorry, what?
Root 3, root 2, root 3, root 4, root 5. They all are natural number.
You think they are all natural numbers? They are all
No.
irrational numbers. They are not natural numbers. They are irrational numbers. Okay? But we still plotted
They are
them on
telling
the
that
number.
M is a natural number or not.
Yes. So, see, if root 2 means if root m is root 2, so m will be 2 only now.
Yes.
So 2, 3, 4, 5. Do you think they are all natural numbers?
2, 3, 4, 5.
Yes.
Yes.
Yes, they are natural numbers. But you're forgetting that we also have negative numbers which cannot be plotted on the number line. You cannot plot negative numbers on the number line, right?
Yes.
Therefore, this statement becomes false that root m, when plotted on the number line, every point on the number line is of the form root m, where m is a natural number. Okay?
Okay. Yes.
Okay.
Every real number is an irrational number.
Okay. Every real number is irrational. Now, this, if you notice, this is the reverse of first statement.
So it's false.
Why? You need to give reason also. False because yes, Khadijah, every real number is irrational. Do you think it's true or false?
False.
Why?
It's false because real number include both rational and irrational.
Very good. Real number include both rational and irrational. So real numbers cannot be only irrational numbers. Okay?
Yes.
All right. Now we have question 2. Please read that.
Are the square root of all positive integers irrational? If not, give an example of the square root of a number that is a rational number.
Okay. Are the square roots of all the positive integers? So please tell me a positive integer.
Are the square root of all positive integers rational?
What is a positive integer? Give me one number which is a positive integer. What are integers?
Positive integer root 2.
In root 2 is not an integer. 2 is an integer. Okay. So are the square roots of all the positive integers. Now, if you have to take the square root of this, are they all irrational? Now we know root 2, if you will divide, if you will solve, the square root will be irrational. Okay. But what about root 4?
Root 4.
Root 4, you can solve the division of root 4, right? It will become 2 into 2. So 1, 2 will come out. So root 4 is equals to 2. Therefore, square root of a positive integer is not rational, is not irrational, right? 2 is rational, correct?
Yes.
So our statement becomes false, that the square roots of all positive integers are irrational. No, they are sometimes rational also. Okay.
Yes. Yes.
Now they are asking you to give examples. So you can give example root 4 is 2, root 9 is 3, root 16 is 4, root 25 is 5, and so on. So these are all positive integers whose square roots are rationals. Therefore, the statement becomes false. Is that clear?
Yes, ma'am.
Okay. Now we have third question where you have to plot root 5 on the number line. So you will take this as your homework, okay?
Okay, ma'am.
Okay, and for question fourth, there's a classroom activity which basically is you have to plot the spiral. The square root spiral is what? We just drew it. This is a square root spiral. Means you draw root 2, then 3, then 4, then 5, and so on. Okay?
Yes.
So you have to draw the square root spiral up to root 7. That will be your homework. Okay?
Okay.
Plot the square root spiral up to root 7. Clear?
Yes, ma'am.
Okay. Now we have the different decimal expansions that we already learned yesterday, right? That if your remainder, now there are few cases that we can study. Case one is, what if your remainder becomes 0? What type of decimal expansion will this be?
Terminating.
Very good. It's terminating because remainder 0 means it's ending. Then you have case 2. The remainder never becomes 0.
The remainder never becomes zero. It's terminating and repeating and terminating and non-terminating and non-repeating.
Yes. You're saying all the words all together, terminating, non-terminating, repeating, non-repeating. Understand the statement. The
Non-terminating
never
and
becomes zero.
repeating.
Non-terminating, sorry, non-terminating. But you cannot define repeating here. To define whether it's repeating or not repeating, you need to see the division, right?
Yes.
So it may be either of them. Okay, you cannot define repeating or non-repeating. Clear?
Yes.
For that, you have to divide and check whether division is repeating or not. Clear?
Yes, ma'am.
Okay. Now we have an example that show 3.142678 is a rational number. So they have given you a decimal number which you have to show is a rational number. Now tell me, what are rational numbers?
Rational number. Show 3.142678 is a rational number.
What are rational numbers?
And
How
the
do you
P by
define them?
Q form.
Very good. The numbers which you can express in the form of P by Q. How will you express in the fraction form or P by Q form?
By 1.
You have a decimal there. If you didn't add the decimal,
Okay.
that was the answer was right then. But since
Okay.
you have a decimal, you remove the decimal, then how many digits are there after the decimal?
30.
How many
What, ma'am?
digits are there after the decimal? 14267 8, no? 3.142678. How many digits are there after decimal?
5.
6, 1, 2, 3, 4, 5, 6. So when you
6.
remove the decimal, you will get 6 zeros as your denominator, right?
Yes.
Okay, so this is P by Q form or not?
Yes.
It has become a rational number now. Okay,
Okay.
now this was quite simple, right? You just had to remove the decimal, the denominator,
Mm,
and you form
yes.
the P by Q form. But what if I say that show 0.3 bar in the form of P by Q? How will you do this one? So this is 0.3 bar. What does bar indicates?
0.333333.
Yeah, 0.33 and so on. Okay. So what we'll do, we'll assume that let 0.3 bar be equal to x. Okay.
Okay.
Just to ease our calculation, x is equals to 0.3 bar. Okay.
Yes.
Okay. So I can write 0.333 and so on. Correct?
Yes, ma'am.
Now, if you notice, there was bar on only one digit. That was 3. Okay.
Yes.
I need to take it out of the decimal. It is on the right hand side of the decimal row now. Correct?
Yes, ma'am.
I need to put on the left.
3.33333.
Yeah, I need to make it 3.333. So how will I make it? I'll multiply it with 10.
Yeah.
Okay, so 10x will become 3.333 and so on. Now I have taken out one whole number before the decimal, correct? This whole 3 is
Yes.
out. So we can say that this x is equals to 0.333 is equation 1. Okay,
What?
I'll say that this x is equals to 0.333 is equation
Okay.
1
Okay.
and
Yes.
10x is equals to 3.333 is equation 2. Got it?
Okay. Yes.
So what I'll do is I'll subtract 1 from 2. So I'll subtract the above equation from the lower one. So what will it become? 10x, the left hand sides get subtracted together and the right hand sides get subtracted together. Clear?
Yes.
So 10x minus x will come on the left hand side and 3.333 minus 0.333 will come on the right hand side. Is it clear to you?
Yes.
Okay. So 10x minus x will become how much?
10x minus x will become 10 minus 10x.
No. X means 1x. So 10x minus 1x. You have 10x. You have to subtract one of them. So how many will be left?
9x.
Yeah, that's it. You will get 9x. Then 3.333 minus 0.333. Now, if you see that the number digits after the decimals are all same, right? So if you subtract
Um,
same number from the same number, what will you get?
3.333.
No, subtract this. What will you get? You subtract same digits from the same digits. You'll get a zero, no?
3. Yeah.
And 3
0.
minus 0 will be 3. So this
Yeah.
will be 3 only.
3.000.
Did you understand?
The 3 by 9.
Yes.
X equals 3 by 9.
First tell me, did you understand this subtraction or not?
Yes, ma'am.
Okay. Now we will solve 9x is equals to 3. So x will become 3 by 9 or 1 by 3.
Ye-
Now it's of the form p by q or not?
Yes, ma'am.
Yes, it is. So that's your answer. Clear?
Yes.
All right. We can take other examples also. Let's say you have 1.272727. One second. 1.27 bar. Express this in the form of P by Q. Okay?
Okay.
Now, 1.27, we'll let 1.27 be equal to x, correct?
Yes.
So, var is on 27. That means both the digits are repeating, right?
Yeah.
So you need to take out this 27 on the left hand side of the decimal. So you multiply it with
Yes.
100 now because bar was on two digits. Okay.
Okay.
So
Yes.
you will multiply it with 100. So it will become 100x and 127 on the left hand side of the decimal and point 272727. Correct?
Yeah.
Now do the same thing. Equation 2 minus 1. Now you tell me what will you get?
100x minus x is equals to 99x.
First tell me the right hand side.
Right hand side 129.0000.
Say the complete statement first. You cannot directly come to the answer. You are doing equation 2, so write this number.
127.2727
Minus
minus
1.
1.2727.
Okay. Now,
Yes.
the numbers on the right hand side are all same, so they will become 0.
Yes.
So you only have to subtract this and this. So 127 minus 1 is
126.
correct. So x will become
126 by 99.
126 by 99. You can cancel this with 9. 9 11s are 99. 9 14s are 126. So 14 by 11. This is P by Q form. Yes or no?
Yes, ma'am.
Clear?
Yes.
Any doubts?
No.
Okay. So there are some questions of this type in exercise 1.2. Take that as your homework. Solve them and we'll discuss it in the next class. Clear?
Okay. Yes.
All right. So I hope you were able to understand whatever was taught in today's session.
Yes, ma'am.
If you still have any doubt in any topic, you can ask me.
No.
All right. So you can leave the session. Have a good day.
Thank you, ma'am.